Okay, so in our multiplying today with our trinomial by a binomial, we have a couple of different ways we can do the multiplication. We can use, I'm not sure which one I want to say here first, the rectangle method model. So I'm going to write that a little bit better than I did. I must need to calibrate. Okay, so rectangle model. So you'll draw a rectangle and you'll do your multiplications within the rectangle, or you can use vertical multiplication, the kind you're used to doing when you multiply a 2-digit number by another maybe 2-digit or 3-digit, or sometimes even a 2-digit just by a 1-digit. We have a way that we can do what's called vertical multiplication. Okay, so yeah, I'm just going to take a moment here and calibrate. It's not being very cooperative. You know what the first thing we're going to do, of course, is what? Change subtraction to add the opposite. Okay, so that's our first move always. If we have any subtraction, we're going to rename them so that they have all addition. So this one doesn't need to be renamed. The other one can be renamed. So let's get that done first of all. Okay, let's do our rectangle model first, since that's the one that was listed up there. Okay, so using a rectangle model to help us do the multiplication. How you decide how you're going to set up your rectangle is by how many terms there are in each of your polynomials. So this rectangle method that I'm going to teach you right now, and actually even the vertical method, can even replace FOIL. So if FOIL is not working for you for some crazy reason, you don't like FOIL, and you say, this rectangle method makes more sense to me, then you can start using the rectangle method even for a binomial times a binomial. Because what we do is we say, okay, I have a 2-term, so I'm going to make my rectangle 2 units long or wide, and then I'm going to multiply by a 3, so I'm going to, and I want to make sure that I have enough room in them. Don't make it too small. I might have even made it just a tiny bit too small, but I want to make sure I can do my vertical over here. So kind of cover half of the page. Okay, we're going to do the vertical on the other side when we're done here with the rectangle. So what you need is really a rectangle divided into 6 sections. The terms x and 3 of the first one are going on our side that's got 2, because it's the 2-term polynomial. And then our 3 terms of our trinomial will go above the columns. So our rows ended up being, they're representing our 2-term binomial, and the columns end up representing, in the way we set it up, our 3-term trinomial. Okay? So notice, we don't even worry about the addition signs right now, just like we don't worry about the addition signs when we're using the FOIL method, but after we get our results using FOIL, then we set it up as an addition problem. We'll do the same thing here, okay? So what you're going to do is, and if you need to write this in there so that you'll be able to remember what you're doing, write the work, or you can just write the answer. What we're going to do is we now have 6 smaller rectangles. And what we're going to do is we're finding the area of every one of those. We're doing 6 multiplications. So we're going to take this x times this x squared, because the length and the width of that first rectangle is x by x squared. So we're going to multiply that, and this is going to become x cubed. We're going to take, in this one, it has a width of x and a length of negative 4x, so we're really taking x times negative 4x for that multiplication. So what's that one going to become? What's the area of that little rectangle? Negative 4x squared. So what we're really doing is kind of finding the area of 6 smaller rectangles, and we're going to add them all together, which would then represent the area of the whole rectangle. What would our next multiplication be in this last rectangle on the top row?
6x.
So we'd have x times 6, which is 6x. So again, Maybe in your notes it's a good idea to at least show what we did to get it, but in your homework, you do not have to show the multiplying. Sometimes the thing to do is, if you are going to show the multiplying, is make one rectangle as your work rectangle, where you're showing the multiplying, and then say equals, and then show it what were the results from your multiplication, so you don't have quite so much busyness going on in them, okay? So this one we're going to take 3 times x squared because its width is 3 and its length is x squared. So we end up with a 3x squared. What would our next multiplication be? 3 times, I didn't ask for the product right away, I asked for the multiplication. 3 times negative 4x, which is? Negative 12x. And what's our last multiplication? 3 times 6, which is 18. Okay. So the part I'm going to put a little blue arrow by, that's the part you could leave out in your work if you want to, but you better make sure you know what you're doing then, okay? You better be getting good results. Let's set up our addition problem now. We now have 6 products, just like in FOIL we ended up with 4 products. We have the x cubed plus the negative 4x squared plus the 6x plus the 3x squared plus the negative 12x plus 18. You better make sure you have 6 products represented in your addition problem. We have the x cubed, the negative 4x squared, the 6x, that takes care of the first row. 3x squared, negative 12x, 18, that takes care of the second row. Okay, now we're going to combine like terms. Now in FOIL, they end up right beside each other, don't they? In this, are they right beside each other necessarily? No, they aren't, are they? So what would we do?
Switch the 3x to the second card and the 6x.
Yeah, or what you can also do is you can just use a way to show that, you know what, these guys are like terms. I'm going to put a box around them. The x's are like terms. I'm going to put a circle around them to show that those got combined. Or you can just rewrite it rearranging it. Okay, that's another way. So now what we want to make sure we do is we want to make sure that we end up with our answer in, we have a whole sheet here to use, don't we? Yeah, we have a whole sheet that we could be using, so we're going to do the vertical below. Okay, so anyway, back to we want our answer in standard form, so what term or terms do we need to worry about first?
X to the second.
In standard form, the variable with the highest exponent on it is most important. So the x cubed comes first, doesn't it? Okay. What comes after 3?
2.
2. Do we have any x squares?
Yes.
Yeah. Okay. So negative 4x squared plus 3x squared. Negative 1x squared. Okay. What comes next? We have 2 followed by 1. So this x's are to the first power. So our x's would be combined next. 6x plus negative 12x. Negative 6x. So basically, this is what we brought those guys together. We brought the circled ones together.
Plus 18.
And then 18 doesn't have anything to be combined with, does it? Okay. Now we'll clean that up. Go ahead and clean that answer up. Cubed minus x squared minus 6x plus 18. Everybody get that? So 6 multiplications, and then just like we do with FOIL, set those into an addition problem. Combine any terms that can be combined because they're like terms. clean up your answer. Okay? So that is rectangle. Anybody have any questions on the rectangle model before we try the vertical? Mikhail?
Well, isn't the vertical just like what we were doing in the last chapter?
Well, we were adding though then.
Oh.
So it's going to be set up like that, it's going to start like that, but we don't have to worry about placeholders. And we get to just do multiplication as if we're multiplying numbers instead of variables, okay? But we don't carry anything. You know, when we multiply with numbers, we have to, if it's 3 times 6 and it comes 18, we just put the 8 down and we carry the 10 to the next one over, right? Okay, we don't have to do that in this one. Okay, how about rectangle? Anything we need to clear up here? Okay, then let's do vertical. So you decide either you're going to do vertical down here because you have enough room, or you're going to do it over there. I'm going to do it here because I think I have it. Well, I can make my paper go on forever. So you decide where you're going to have enough room to do the vertical model. You want to do it over on the side because you did leave enough room. Okay, so now when we do these, it'll make a whole lot more sense, just like it does when we're multiplying a triple-digit number by a double-digit number. Which one do we put on top? We put the double digit up on top or the triple digit?
The triple.
Triple digit. Do the same thing with your polynomial. So we're going to put our trinomial, which is what? I don't even remember it. It is
Plus
x squared plus negative 4x. Okay, so x squared plus negative 4x plus 6, is that what it is?
Yep.
Okay. And then the other one is what?
X plus 3.
Okay, so you set it up just like you do a multiplication problem, except this has got some addition signs in the middle. Because by the way, we could put addition signs when we write the number 783. We could really put addition signs between them. But if we do, then we got to give them their full name. So 783 with addition signs between it would be what? What would that look like? 783. I'm just taking a little sidetrack here because I want you to be, I want to check your math knowledge out here. 783. Would I write it? Could I write that like this and it would mean the same thing?
No, you have to write it 700 plus 80 plus 3.
Yeah, that's how I could write it if I wanted to write it as an addition problem, couldn't I? So we really can still even write just numbers as addition problems, but we don't do it. Aren't you happy we don't have to do that for a triple-digit number? Or maybe a 10-digit number? What if we had to write them all like that? That'd be kind of crazy, wouldn't it? So what we're going to do is now we're going to multiply, though, as if we are multiplying with a number. We're going to say, I'm going to start right here, and I'm going to take 3 times 6, which is 18. But I don't just put the 8 down and carry the 1. I put 18. And I have to bring my addition signs along this time. So in the rectangle, we don't have the addition signs there, but we do in the vertical. So now I go over here and I say 3 times. So basically I just did this, right? Now I'm going to move over here and do that one. What's 3 times negative 4x?
Negative 12x.
Negative 12x. Bring down the plus sign. I got another multiplication I'm going to do. I'm going to take that 3 times that x squared. What is that?
3x.
3x squared. Okay, everybody follow all of that before we move on? Yeah, we got that? Okay. Now, when we multiply with numbers, do we put it right here?
No, you put a 0 there.
We put a 0 here, don't we? I typically don't, but you can put a placeholder of 0 there. I just leave it blank. Personally, I just leave that blank, but you can put a plus 0 there. And now we start this multiplication. We say, now I got to take the x times the 6, which is what? 6x. Bring down the plus sign. I got to take the x times the negative 4x. Negative 4x squared. There's still another plus sign to bring down. It's just kind of got moved over here.
X.
And now I did that, and now I got to do that one, don't we? What's x times x squared?
X to the 3rd power.
X to the 3rd power. So notice they're still lined up in columns of like terms, aren't they? So try to do that. Keep them lined up in columns of like terms. And now we'll just add it up. So 18 plus 0,
18.
18. Bring down our addition sign. Negative 12x plus 6x.
Negative 6x.
Negative 6x. Bring down our addition sign. 3x squared plus negative 4x squared.
Negative 1x.
Negative 1x squared. Bring down our plus sign. X cubed plus nothing. X cubed. Now, compare that to our addition problem after we did our rectangle multiplication. Before we added them and cleaned them up, does that look like our addition problem from up here necessarily?
Yes.
Yeah, after we combine like terms, look at right there. Before we cleaned it up. Here it is. So we have the same thing. We got the same result, just went about it a little bit differently. Now we'll clean up our answer. So just like we cleaned up the other one, we always clean it up. How will it look in an answer bank? When I take that ACT test next year as a junior, how will that answer look in an answer bank? Questions on vertical. Which one do you like? The choice of the rectangle? Does that work better for you? Typically, the rectangle does work better for people than the vertical does. But, we'll practice it both ways again on the back side. Don't we have another one to do? We'll practice it again. And then when you're doing your homework, you don't have to do it both ways. You can pick which way you're going to do it. Okay? So let's go to the back and do that next, the one back there. Okay, you go ahead and do what you know you absolutely have to do first. And trust me, if you don't do it in these, you're going to be wasting a lot of lead and being really frustrated when we correct your papers on Monday. Okay, now, I just want to show you that when you're doing your rectangle multiplication, you might set it up as a 2-row by 3-column. Somebody else might set it up as a 3-row by 2-column. Should we still end up with 6 multiplications?
Yes.
Yes, because multiplication allows you to either multiply 2 times 3 or 3 times 2, doesn't it? So let's just switch this one up to show you that it can have a different look, okay? Let's put the trinomials terms on the side, and let's put the binomials terms on the top. So the trinomial is claiming the rows this time. And the binomial is claiming the columns. It doesn't matter. So 2 by 3 or 3 by 2, you get to do it either way. Okay, go ahead and fill that out. Go ahead and do your multiplying. And let's see what 6 products we all end up with. So again, like I said, maybe you want to do this. Maybe you want to have a work rectangle and you want to have a product rectangle. So in that one, you would be showing your work, and in this one, you would be showing what the results are. So I'll do the work one and you go ahead and finish, and then you're going to give me the answers. One of the reasons I like to set up like this is because it shows that each term of the binomial is getting multiplied by each term of the trinomial. Because Look at right here, it shows. Each term of the binomial, so the binomial term 3x is getting multiplied by each of the terms. So it gets each of them. All of them are getting covered. The other term of the binomial is getting multiplied by every term of that one. All of them are getting covered. You're making sure, because what we're really doing is distributive property with 6 arms. Kind of what's happening. So tell me, what does my product rectangle look like? What's the first rectangle here say?
3x.
Squared? To the third power. Okay, how about the next one over? Okay, negative 2x squared. How about the first one in the next row?
6x squared.
6x squared. How about the last one in that row?
Negative
4x.
Okay, how about the first one in the last row?
Negative 15x.
Okay, and the last one?
10x, or 10.
Positive?
Yes.
Everybody agree? We got, all of us have these products? Okay, what do we do next in rectangle? Yeah, write them all down in an addition problem. So 3x cubed plus, okay, I'm going to show you something because I want you to maybe get to take a little shortcut here. Sometimes, not always, but most of the time, when you look at the diagonals and the rectangles, you will see like terms. See that? Here's another diagonal. Are those like terms?
Yes.
So sometimes I like to do that. I like to group those with circles around them like that. And then when I'm writing my addition problem, I can just put them in that order. Now I would next say I'm going to add the 6x squared plus the negative 2x squared. And then I'll take that negative 15x, it'll be next, plus my negative 4x. And then I got to remember that I got that 10 down in the corner by itself. So then I don't, they're all kind of arranged already. They're kind of grouped in the rectangle that way. Michaela?
Can you like, okay, so when you're just writing it down, if it's not like diagonal or anything, can you still just like in your head think like, I'm going to use that one next, then just kind of put like a little X on it and like kind of group them together?
Yes, you can do that. Mm-hmm. Yeah, I understand what you're saying. Yes, you can do that. Okay, anybody else have a way that they want to do it, that they think, would that work? Okay, so now we're going to get our, combine the things that can be combined. Because 3x cubed have anything to be combined with? No. How about the 6x squared? Okay, these guys can be put together, can't they? It becomes 4x squared. How about the negative 15x? It can be put together with a negative 4x, can it? How about the 10? It's by itself. It doesn't have anything to do. Okay, now we'll clean it up. We do have to clean this one up. 3x cubed plus 4x squared minus 19x plus 10. Okay. Now, how would this work with a binomial times another binomial? Because I said the rectangle method could be used anytime you want. So a binomial times a binomial. What kind of a rectangle would we have, Noah?
2 by 2.
A 2 by 2. What if you wanted to use it for a binomial times a monomial? 1 by 2. What if you wanted to use it for a trinomial, which we haven't done yet, times a trinomial?
3 by 3.
A 3 by 3. So how many multiplications would there be in a trinomial times a trinomial? 9, because 3 times 3 is 9. You should end up with 9 multiplications. So you get a picture of how many multiplications this would be and how the rectangle method could work for any of them. So if you're like, I just really like this rectangle method, I'm going with it all the time, you can. Okay? Vertical. What's going on in the first line? Faith? Read it to me, please.
X to the second plus 2x plus negative 5.
Okay. What's going in the second line? Calvin?
x to the second plus 2x.
I'm gonna take that one times itself. Didn't you just give me the same one Faith gave me? Aren't you giving me the same one Faith gave me?
No.
Okay. Sorry.
Minus 5.
Oh yeah.
Oh, whatever, you just put what I said. So.
Okay. So can you give me the second one now instead? Let's try again. I'm gonna give you another chance. Here we go. What's the other multiplier? What's the binomial, Calvin? Come on. Come on, multiplier in. Come to his rescue. Abby to the rescue. 3x plus negative 2, the other polynomial. Okay. Now, what if it was a trinomial times a trinomial? Would it matter which one's where?
No.
No, because they both are 3 terms, aren't they? Okay, so when one has more terms than the other, we put that one on top, the other one gets the second line, and now we start our multiplying. Okay? So we have this has to be multiplied there, there, and there. We got 3 multiplications to do. Negative 2 times negative 5.
10 positive.
10. Bring down the addition sign. Negative 2 times 2x, negative 4x. Bring down the addition sign. Negative 2 times x squared.
Negative x squared.
Everybody's doing this, right? Let's go. Come on. Okay, go ahead and do the second line now. You do the second one. Okay, would somebody go put theirs up there for me, please? Thank you. Just the second line. Okay, thanks, Cody. Okay, everybody agree with Cody? Maybe to change his mind on anything? So, this is the 3x is now getting multiplied times each piece of the trinomial. So apparently 3x times negative 5 is negative 15x, 3x times 2x is 6x squared, and 3x times x squared is 3x cubed. Okay, looking good to me. Anybody want to disagree for any reason? Okay, does it matter which end we start at? Because so we can just start bringing them down, can't we? Plus, what's a negative 2x squared plus a 6x squared?
4x squared.
Plus, I should try and stay in line here. Negative 4x plus negative 15x.
Negative 19 squared. Or negative 19x.
Oh, we're adding, not multiplying, yeah. Those stay x's. And then plus
10.
10. Okay? Can we leave our answer like that?
No.
No, that's not how we're going to see it in that answer bank. Okay. So now have you formed an opinion? You can couple of them. All in favor of rectangle, it is so cool? Yeah. Vertical? Vertical's my favorite way too, actually. Okay, so let's get busy on your homework then. Let's carefully write down your, I'll put it up here for you too, so that you make sure you write down the problems that you should do. I have you multiplying binomials times trinomials, and there's other choices within that, of course, so this is the only one I wanted you practicing today. Okay. I'm gonna write them down, but I just, my recorder, I don't think it stopped, I gotta